Hello and welcome, ladies and gentlemen, for a new episode of how to write good bash scripts, or at least my practice is to make bash scripts clearer and less prone to errors, because bash is a weird language. There are many pitfalls in there. But it's very useful to just automate whatever you want easily, especially if you work a lot with the shell, and I definitely encourage you to work with the shell. That's the point of my YouTube channel, actually, and many of the things I'm doing. So I wanted to come back to three things actually. First thing, I wanted to remind you on what script we are working on, because this is a series of video. If you didn't watch the other video before, I definitely encourage you to do that. And we were writing a script to copy every directories and subdirectory from a source directory to a destination directory for backups, for example. And that's why the script is called backup. That's super logical. So as you can see in our example here, in destination there is nothing, and in source there is a lot of stuff. So if I do backup.sh, everything which is in the directory source will be copied in the directory destination. And to prove that, now in destination there is everything which is in source as well. Now everything is copied. So let me delete everything which is in destination. And now we don't have anything in destination anymore. Here we go. So second thing I wanted to come back to is the shebang here on your left. You will see in many bash scripts a shebang like that, bin bash or maybe user bin bash. It's not that good for portability, because if you declare the shebang like that, the problem is you assume that on every system your script will run, bash is located in bin bash, which is not always the case. If you do user bin bash like that, it's the same. You will assume that bash is in user bin bash, which is not necessarily the case. If we do that, user bin environment and then bash, what the system will do, it will go into the path variable, which is an environment variable, and it will look where bash is in this specific system, which is way better because it doesn't assume that bash is somewhere specific. So it's more portable. I would definitely encourage you to do that for all your bash script, to use this shebang. Third thing about this, as I was explaining in another video, it's better to use these options because you have a better error handling throughout your script when you run it. Now it has some pitfalls as well, so it won't necessarily catch everything depending on your script, or sometimes it will do weird errors. So keep in mind this. Maybe we will come back to those pitfalls in another video. But for now, with bash, I always assume that there will be a problem, and because the language is so weird. All right, so what do we do today? We will improve the readability of our script. And to do that, first, why we are doing that, it's because, as you can see, the block of code is quite ugly, and more importantly, it's difficult to understand. When I'm writing something like a script or anything in a code base, I always ask myself when I come back to it, okay, if I didn't know anything about it, anything about the project or anything about what I'm doing, would I understand the code easily? And I think it's very important because code is meant to be shared at one point. If I put that in my dot files and somebody sees the script and is interested by it, or if you watch this video and you want this kind of script, it's better to understand it like that. You can modify it depending on your needs. for example. So let's make that a bit more clear. And the first way to do that is to create function. So there are two ways to create function in Bash. You can do function handle arguments, for example, like that. Super easy, nothing really to say here. You can as well do that, handle arguments, without the function keyword. But I always prefer putting the function keyword to be very clear of what it is. All right, so let's create this function and let's put all of that in there. So basically it means, well, handle the argument of the script. Makes sense. Now there are a couple of comments, as you can see, and I will delete them. I don't always delete the comments, but this one are not really useful, I think. They come from the snippets I have with Neovim. And I prefer naming stuff with my function instead of putting comments. If I put comments, it will always be high-level comments, in the sense that it won't describe the code itself, but it will describe the intent of the code or some tricky part developers can't understand with the code. Because to me, if the code is saying something, we shouldn't add comments to say exactly the same thing. Because when you change the code, you won't necessarily change the comment, which will bring some misconceptions, doubts, many nasty things. All right, so here I created a new function handle arguments, which handles the arguments basically of the script. There is a function usage here I will rename, because it's not really the usage, it's the help, and I will rename that as well here. So it's basically, the function help is to output the help when I do backup .sh minus h. It's not minus. Oh yeah, it doesn't work yet because I changed the script, but yeah. So that's one function. The other function would be, in that case, all of that, because we have only that left. And this is basically the heart of the script. And I always use the function run for the most important piece of the script. So let's declare our function run. Let's do that. Okay, so now we have our function run, and the first thing we should run is the function run. Makes sense, so let's run it here, and let's run it with every argument we pass to the script itself. This means every argument given to the script. So normally like that, it would work, but without argument, because my function handle arguments is not called. So I need to call it. I need to call it here, but first I need to declare my rsync option. If you remember, this is an array where I have all the options of the call to rsync, because in the script I call rsync to copy everything which is in the source to the destination, as we just did at the beginning of the video. And depending of the argument we give to the script, either way it will be a dry run, which means that nothing will be copied, but the output will tell me what would be copied if I wasn't doing a dry run. So it's just a security to see how the script behaves without doing anything. So I need to have an array with every option given to rsync, because I can add the option dry run depending of the argument I give to the script. So here we have the option, And you can see here at the beginning of the script, we add the option dry run to the array if the dry run or the option is given to the script. So in my function run, I have rsync option, and then I need to handle the argument. And again, I pass to handle arguments every single argument which is given to run. So to summarize, first, when we run the script, the last line will be executed, which is run with all the arguments given to the script here. Then in the function run, we create a new variable, which is rsync opt. And then we call handle argument, which is another function declared here on line 9. And we pass to this function handle arguments again every single options we passed to run. So every single option which was passed to the script at the end of the day. And then in handle arguments, this option will be passed, and depending on what it is, some action will be done. So first of all, and then rsync option is used with rsync to just call rsync with all the options we want. So let's try. Let's try first backup.sh with -d, which means dry run. We just test the script without doing any action. And it works. You can see here, it's a dry run. So very good. If I do -h, it will display the help. So the handle argument work well, apparently, and if I do backup.sh, and if I do backup.sh, I just run it, and if I do tree destination, you can see that it worked. To be sure, I will delete everything in destination again, run backup again. Apparently it worked. Tree on destination. It works. I have everything which was in source also. So it worked great. So now why we created those functions? I really like to do that because it really explains what every piece of the code is doing. So handle arguments, well, it handles the arguments of the script. Help, just output the help. I mean, if we wanted to be even more precise, we could do output help and rename it here. Oops, and here. So output help, output the help, and the function run is the core of our script, which will do everything else basically. So it really segregates, it separates all the different concerns of our script. And if you are new, and I mean, if you don't know the script and you want to modify it, already you will see what does what, which is nice. Now, I would like to come back on how it works, because there is one important thing here to know with bash scripts, and it's the dynamic and lexical scoping. So in modern programming languages, it's always lexical scoping, which means that you see here my function handle arguments is declared, and it will use an rsync option here, which is a variable. Now, if I declare in the scope which is above it, in the global scope, let's say that I declare rsync options equal dummy. So it's an array. I just declare a variable rsync options. In a lexical scope, in a language, with lexical scoping, it would mean that rsync opt here is added dry run to the dummy argument, because Since in handle arguments function there is no rsync options variable declared, it will go on the scope just above it. And the scope above it is the global scope. In the global scope, the runtime will find rsync opt and it will find this one. The thing is, Bash is not a lexical scoped language, but a dynamically scoped language, which means that if a function doesn't find a variable which is used inside the function, like rsync opt, it won't go in the environment above the declaration of the function, but above the call of the function. So it means that the function is called here, so the environment which is above handle arguments is not the global environment. It's the environment which is above the call and not the declaration. So above the call, it's the function run. So this rsync option will be used, this declaration of rsync option will be used instead of this one. And we can look at it now. Let's say that I do here an echo rsync option. And if I run backup.sh with -d, you can see that here we have the output of rsync option, which is not dummy, as it would be with a lexical scoped programming language, but it's with avz and delete. Actually, I should have done that. It's not very good what I did, because you don't echo an array like that, but more like that if you want every values. And here it's very clear that the array use the scope which is above the call and not above the declaration. I'm not sure it's very clear, but it's quite important. And it's funny because, yeah, you will never meet that again with a more modern programming language. Definitely not. Okay. So that's all for today. I hope you learned something. If you like this video, you know, like it, follow me. Please, the mighty YouTube algorithm with your prayers. And thanks a lot for watching. Next time we will continue this script to see more stuff. I'm not sure what yet. And have a great rest of your day.